We are dealing with problem number 10. Figure given below shows a smooth track, a part of which is a circle of radius r. A block of mass m is pushed against a spring of spring constant k, fixed at the left end, and is then released. Find the initial compression of the spring so that the block presses the track with a force mg when it reaches the point P, where the radius of the track is horizontal. So for this particular problem, if I draw the requirement over here, so at this point P, when the block reaches over here, it is having a speed v, instantaneous speed v over here. So it will be exerting a force which is equal to mv square by r in this direction, and it is balanced by a reaction force which is equal to mg in the inward direction, as the problem is stating that the block presses the track with a force mg. So over here, if I write this equation, so I can write it as mv square upon r is equal to mg, that is v square is equal to rg. So now if I talk about energy conservation, so I can say that over here energy is stored in a spring is converted into the kinetic energy of block, which in turn at a point P is equal to kinetic energy of block plus the potential energy which is attained while moving to a height equal to r. So according to this expression over here, the spring potential energy was converted into kinetic energy, and the block will start rising up to a point P. And if I write this expression over here, so I can say that the spring potential energy can be written as half k L square, where small l is the compression in the spring, and then we are equating it with the right hand part, that is kinetic energy of block plus potential energy at point P. So kinetic energy at point P is equal to half mv square, that is equal to rg, and it is at a height r, so it is equal to mgr. So for this particular problem, I can say that half kl square is equal to 3 by 2 mgr, and the value of l will become 3 mgr by k root over. So this is going to be the value of compression that is needed in the spring so that it reaches a point P and presses the track with a force mg.